In this video, I'll show you how to solve the ALEKS problem called identifying hybridization in a small molecule. To solve this problem, we're going to need to look up the Lewis structure or draw the Lewis structure for the molecule in the problem. There is no way around this, no shortcuts, although actually looking up a Lewis structure is really a shortcut. So I'm going to be using the internet to look up the Lewis structure of ICl4- rather than draw it myself. And I'm going to warn you again that when you do this, you just want to make sure that you're getting an accurate Lewis structure. There are a lot of molecules that have similar formulas. ICl4 is one of them. There's an ICl4 plus, and then there's also an ICl4 minus. So you want to make sure that you're definitely finding the correct version of this molecule. So once we have either drawn or found the Lewis structure, we're going to be looking at the Lewis structure to get information about the hybridization of the central atom. The hybridization is, if it's not explicitly stated, so if the problem doesn't say what is the hybridization of a particular atom, it's always going to be applying to the central atom, in this case, the hybridization of iodine. In order to determine the hybridization, you need to determine how many areas of electrons are around the central atom. And an area of electron could either be a bond or a lone pair. Double bonds count as one area, triple bonds count as one area. So this central iodide atom has 6 total areas of electrons. And it doesn't matter in this case whether they're bonds or lone pairs. We have 4 bonds and 2 lone pairs. The hybridization, like I said, is based on the numbers of areas of electrons. When you have 6 areas of electrons, the hybridization is sp3d2. If you have 5 areas of electrons, the hybridization is sp3d. Now, I'm actually going to show you kind of a shortcut to help you remember. And what I'm going to do is write out the orbitals. In general, in any energy level, there is going to be 1 s orbital. There are going to be a total of 3 p orbitals possible and a total of 5 possible d orbitals. So like this is the maximum number of orbitals you could have in any energy level. If you have a total of 6 areas of electrons around a central atom, you're going to need 1, 2, 3, 4, 5, 6 orbitals for hybridization, and that amounts to 1 s and 3 p's and 2 d's, and that's where we get this number from, or this notation from. So if we had, let's say we had 5 areas of electrons, we would need 1, 2, 3, 4, 5 orbitals. That would be sp3d. If we had 4 areas of electrons, that would be sp3, and you get the idea, and that makes it, that's kind of a nice and easy shortcut you can use.